Hello friends, we are back again with the IUPAC nomenclature of the complex compounds. In the previous session we just had an idea, a simplified idea, you can say a brief idea regarding the complex compound. Now there are, as I said in the previous episode, the ligands are of two types basically, the negative charged ligands and the neutral molecules. So these are the two types which are bonded with the central metal ion. Just giving you most of the ligands I have briefed over here so that the video becomes short and you can get the idea in no time. I'll just give you a brief idea over here regarding the type of ligands that I have specified on the board. See, these are the monodentate negative ligands, means they will have a tendency to provide 1- charge, and that will form a coordinate covalent bond, one coordinate covalent bond with the central metal ion. There are a few over here which are in general used, most of are repeatedly used for the complex compound nomenclature. For example, if it is OH with 1-, we name it as monodentate negative ligand. OH- for IUPAC is named as hydroxo, XO. There is a suffix you can see O over here, so it is named as hydroxo. For Cn-, in general it is cyanide, but for the IUPAC nomenclature it is named as cyano. For CnO-, interesting, CnO-, it is cyanate, and for IUPAC we name it as suffix O, cyanato. For NO2-, here you will have interestingly three ligands where you will have minus charge, all the three will have 1- charge, the nomenclature varies. Let's see how. NO2 with 1-, it is named as nitro, simply nitro, suffix O, nitro. But if the metal is bonded with not nitrogen and oxygen, we write it as ONO. ONO, oxygen is bonded to the central metal ion forming a coordinate covalent bond, and that is forming one coordinate covalent bond, but it is not named as nitro. Interestingly, it is nitrito. Instead, if there are 3 oxygen with nitrogen, we name it as a nitrato, because the ion is nitrate. Here the ion was nitrite. Actually it is nitrite ion, but IUPAC we name it as nitro. If the oxygen is bonded, then it is nitrito. Here NO3- is nitrato. Similarly, if there is NH2 group with minus charge, so it is NH2- ion, we name it as amido. If it is SCN-, sulfur bonded to the cyanide, then we name it as sulfur, named as thio, so it is known as thiocyanato. If it is CNS, carbon bonded, and in the previous one it was sulfur, this is iso because sulfur is written beneath the cyanide group, so it is iso, and rest name remains as thiocyanato. Now interesting, as far as halogens concerned, we don't name them in the regular fashion. We used to name them in the organic nomenclature as chloro, but since 2004 IUPAC has given a new variety to name the halogen group elements. For example, if it is Cl-, we name it as chlorido. If it is Br-, we name it as bromido. So this is, you can see I have given a list as far as the board capacity concerned for the monodentate ligands which are negatively charged. We move on to the next one, that is bidentate ligand, again negatively charged. One is CO3 2-, bidentate. It is known as carbonato. It's carbonate ion, so IUPAC has suffix O, carbonato. SO4 2-, suffix O, SO4 2- is sulfate, we name it as sulfonato. Similarly for SO3 2-, it is sulfite, so we name it as sulfito. O2-, oxo, suffix O. OX 2-. Now that can be, denoted with OX and C2O4 in the actual form. This is oxalate. This is the symbolical form of oxalate. Both are oxalato. This is symbolical representation. This is formula representation. Similarly, you can go with tridentate ligand with negative 3, that is minus 3 charges. PO4 3 minus, so that is phosphato. Arsenate ion, so we will name it as arsenato. So this is a brief idea I have given regarding the negative charged ions. Now there is another variety of ligands, and that is we consider them as neutral ligands. They are again of 3 types: monodentate, bidentate, tridentate. Monodentate is H2O, water. Interestingly, we don't give a suffix O to such type of ligands. Instead, you can see over here, water is given, it's aqua. Water is aqua. So we write it as aqua. NH3 is amine, A-M-I-N-E. But for IUPAC, mind you, you need to write double M. It's amine. This is aqua. This is amine. Here nitrogen has a lone pair over here which will form a coordinate covalent bond with the central metal ion. Water has oxygen which has got 2 lone pairs, but the capacity of forming a coordinate covalent bond is only 1, and that is why water is considered to be a monodentate neutral ligand. If you consider CO again, it's oxygen. So obviously for oxygen there will be 2 lone pairs. But the capacity to form the coordinate covalent bond is 1, and that's why we have included it in monodentate neutral ligand, that is known as carbonyl. Carbonyl, NYL. Similarly, if you consider NO, then it is nitrosyl. If you consider CH3NH2, CH3 is 1 carbon, we name in general as methane, NH2 is amine, so accordingly we have given the name methane amine. So that is a monodentate neutral variety. Similarly, we can move on to bidentate. Bidentate means it will have a tendency to form 2 coordinate covalent bonds with the central metal ion. Here you can see I have written, it is CH2NH2, CH2NH2. So that is what? It is your 2 carbon ethane, 2 NH2 groups, where they are on first carbon and second. So we have named it as ethane 1, 2, 2 amine groups, so it is diamine. So it is your bidentate ligand because 2 nitrogen both will form 1-1 coordinate bond with the central metal ion. If you consider the next one, I have written CH2, CH2, CH2. On first and the third carbon there are 2 NH2 groups, so it is propane 1,3 diamine. We move on to the next one, that is tridentate ligand. It is 3 carbon with 3 amine, all the 3 forming 1 coordinate covalent bond with the central metal ion. So we name it as propane 1,2,3 triamine. For IUPAC, instead of E, we add the suffix, and so it is ethane 1,2 diamine, propane 1,3 diamine, and propane 1,2,3 triamine. So this is the brief idea I have given you before we actually start the nomenclature of the complex compound, because it is equally important to know how to name the compound when it comes to the actual find. So just keep these things in mind, be prepared, and get ready for the next episode that will be directly focused on the IUPAC nomenclature. Brief yourself. All the very best.